Next we come to metal carbonyls. Metal carbonyls are those in which the metal is bonded to CO, like your NiCO4, FeCO5. All of those are metal carbonyls. But first of all, in order to study metal carbonyls, to study the bond lengths and everything, we need to know what happens when you put an electron into CO or you take out an electron from CO. In the molecular orbital diagram of the CO, the electrons which have to be taken out, the electrons which can be taken out, they are present in non-bonding orbitals. That is, you can take out the electrons from the non-bonding orbitals. When you take out an electron, you form CO positive. And when you give an electron, you form CO negative. And in CO, according to the molecular orbital diagram of CO, you have to give the electron to the anti-bonding orbital. That is the pi star. That is why it is a pi acceptor. That is d pi star ligand it was. So that is why, because the anti-bonding is the one which takes the electrons. So CO negative is formed when the electron is put into the anti-bonding orbital. Now we know that the bond order is equal to half into number of bonding electrons minus number of anti-bonding electrons. So as the number of anti-bonding electrons increases, the bond order increases. Therefore, the bond order of the CO negative is going to be the least, because as the number of anti-bonding increases, the bond order decreases, because anti-bonding is getting subtracted. So as the anti-bonding number of electrons increases, the bond order is going to decrease. So because the anti-bonding is decreasing, the bond order is going to decrease, and the bond order is going to decrease. That means CO negative will have the least bond order. Then CO positive and CO. Technically, CO positive should not have affected the bond order, because you are taking out an electron from the non-bonding. That should not affect the bond order. But the thing about the CO molecular orbital diagram is that this non-bonding orbital from which the electron is going to be taken out, this has slight anti-bonding character. So if it has slight anti-bonding character, taking out the electron from that non-bonding orbital, it stabilizes the molecule. Stabilizes the molecule and it increases the bond order. So that is why the bond order of the CO positive is greater than the neutral CO, which is in turn greater than CO negative. And we know that the bond order is directly proportional to the bond length. That is, as bond order increases, the bond length will decrease. Now, as the bond extent of back bonding increases, back bonding means what? Like metal, your ligand is giving to the metal by forming a sigma bond. Metal is giving back to the ligand by forming a pi bond. This is back bonding, that the metal is back bonding to the ligand. As the extent of the back bonding increases, the bond order of the MCO bond increases. Right, that the metal and the CO bonds bond order will increase, because it is becoming a pi bond. Right, so the bond order is going to increase, and if the bond order is going to increase, the bond length of the MCO bond is going to decrease. This will be decreased. That is, if the bond length of the MCO bond order is increasing, then the bond length is going to decrease.